Hello friends, welcome back my YouTube channel MS Maths. In this video I will discuss the topic related to the function of several variable, basically multivariable calculus. I will discuss almost all topics of related to the function of several variable with practice problem, lot of solve problem, and keep watch this video at the end so that the topic will be clear to you guys, and then it is very easy. Again, the video will be a bit lengthy, but there is timeline in this particular video. You can click on the timeline to watch that particular topic. Okay, now we'll proceed forward. So first of all, we'll see the domain and range of the function. Okay, then we will proceed for the level curves of the function of two variable, and then limit of function of two variable, how to find out the limit, how to approach the question in your exams, that we will see. And then continuity of function of two variable, how to find out the continuity, how to check the continuity, basically whether my function is continuous or not. If it is not continuous, how to check. Okay, all these things then we will see. Then we'll discuss the partial derivatives of the function, different formulas of the partial derivative, and basically what do you mean by partial derivative, that I'm going to explain in this video. And then it is a partial derivative related to the basically chain rule. Okay, this is partial derivative related to the chain rule that we will discuss here. Later we will discuss the finding extremals and saddle points, so basically maxima and minima of the function of several variable. And then we'll see the maxima and minima using one of the powerful method that is called Lagrange's method, that we will see. So we'll see around 8 topic in this single video. Using the timeline, you can watch the specific topic, or I will suggest you start from the basic, let's say domain and range of the function, that it will be very easy to understanding for you guys. So now let's start the topic. So domain and range of the function of two variable. Okay, function of two variable, what is the function of two variable, that I will simply explain you. So y is equals to f of x is called function of one variable. Okay, so it is function of one variable. It means your y is totally depending on this x. This is called function of one variable. And we know that any function, let's say I have this f function is a machine basically. So this function is defined from, let's say, some a to b. So this a is called domain is something from where I will take the input. So my x will be belonging from domain, and y will be belonging from this b set, and this b set is known as codomain. It means codomain is the collection of, it is a set, basically it is the collection of all possible outcomes. Okay, and domain is the collection of all inputs. Okay, that is the input. So I will put all those points in the domain at which my function is defined. So similarly, I will remove those points from the set where my function is creating problem. Such function, like such domain, such set is known as the domain. Okay, now next thing is that what do you mean by the range of function? So simply range of function means that the exact outcomes. Okay, let's say I have x square. If I will put 1, I will get 1. If I will put 2 in this function, I will get 4. Okay, if I will put 3 in this function, I will get 9. So these are the exact outcomes of my function. So these are known as the range. If I will write down all these exact outcomes in a set, so this set is known as range set for this function. So keep in your mind, this is called domain, this is codomain. Okay, and the codomain and the elements within the codomain which has a pre-image, basically which is related to this domain, which is called something range of this function. This is all about function of one variable. Similar story for the function of two variable. Let's say I have w is equals to f of x comma y. This is called function of two variable because of that w is depending on two variable. Okay, two independent variables. So let's say here the domain will be r2, or any subset of r2 that will be in form of x comma y, and is belonging from r cross r. This is nothing but the order pair. Okay, nothing nothing to worry here. This is just simple from extension of function of one variable to the function of two variable. If you will go to the geometric meaning, it will represent a curve, it will represent a surface. Okay, and we'll call it as a function of two variable or function of several variable. It may be like this, function of several variable. Let's say this is called function of three variable. If it is 4, then function of 4 variable. So instead of using these words, we can more generalize, more precisely it is a function of several variable. Now come to the point how to find out the domain and range of the function of several variable. When we will have this kind of problem in your exams, then how to hit that problem, that is our ultimate goal. Okay, so now come to the function of several variable. Let's say my f is function of two variable here, then domain is the set of all possible input in xy plane. Because of that, the graph of this function of two variable will be in let's say in your it will be in the 3D case. Okay, so here check for, keep in your mind 3 points. First one is check for denominator is not equals to 0 for any rational function. Okay, this expression inside square root should be greater than 0, and logarithmic argument, okay, whatever written inside the logarithmic, that should be greater than of 0. It should not equals to 0, it should not be negative. So keep in your mind 3 point, then we can proceed forward. While finding the range set of highest z value, what is this like z value? So simply I will define my z is equals to f of x comma y. So I am calling this is z value. Okay, so this is z is equals to f of x. Find out the highest, or let's say maximum value of that z and minimum value of that z, then you can get the simply what is the range and what is the minimum and maximum, and easily you can find out the range. Okay, and then you can find the vertical values taken by the surface. So what happened in your, if you'll see in the graph, so it will be your z axis, it will be your x axis, it will be your y axis. Okay, so it will be something like this. I can draw here. This is, so here this is your domain, and this will map to here. So this function is from where to where, R2 to R. It is called your function of several variable, because when you will put two inputs, you will get one output, that is your x comma y will be mapped to a single number, that will be your R, which is your codomain. Okay, so R will be this z axis. Anyway, how to solve the problem, that we will see. Let's say we have this problem. Now how to solve this problem, I will explain step by step what is the step to solve this particular problem. So first step, what you should follow. Okay, since function, I told you, I have given you three rules. Whenever it has, just see which function is this function is a square root function. If you have any square root function, I told you whatever written inside the square root, it should be greater than of 0. Then what is the written inside, that is 9 minus x square minus y square. So you can write down like this: since the function contains a square root, then the expression 9 minus x square minus y square should be greater than equals to 0. Or after rearranging this, I can simply write down 9 should be greater than of x square plus y square. Okay, this is the condition. Okay, keep in your mind, this is the condition, or you can say the restriction for your x comma y. If your x square plus y square is less than of 9 or equals to 9, then only this function is defined. If any of the x and y which is not satisfying this condition, you can't take that x comma y, or you can simply say for that x comma y your function will not be defined in that case. This is the condition. Now how to write the domain? I will simply define domain with the d. Because of that, this is a domain, and domain is a set. So you have to write in the set form, that is something like x comma y. Okay, so you try to understand, this is x comma y belonging from R2, because this is the shape of R2, such that those x comma y which is satisfying this condition, x square plus y square less than of 9, this is your domain. This is not the domain, this is the condition for the domain. Okay, this is the condition for the domain. And now we'll say, what do you mean by, what is the geometric representation of this? So it is nothing but it is, this represents, so basically this represents a closed disk. Okay, this represents a closed disk of radius 3. Okay, this represents a closed disk of radius 3. Now we'll say, so what do you mean by the closed disk? See, this is something here. Just try to understand. Let's say I have this disk here. Okay, I think it is not visible. Let me change the color itself. Yes, so from here, if I will write down, let's say this is the thing. Okay, So let's say this is the disk. So okay, this is the x-axis, this is y-axis. Okay, or one more thing, to define this I'll simply write down here, let's say this is my x-axis, okay, and this is y-axis. So I'm just giving you the meaning, physical meaning of this, or you can say the geometric meaning of this. What is the meaning, what is the geometric meaning of this, that I'm going to explain you. So let's say this is your x-axis and this is your y-axis here. Okay, so in this you can see this is the closed disk. It means each and every point within this disk or at the point of this disk which will satisfy this condition. Now you can take, let's say, x1 comma 1. Okay, if we'll take 1 comma 1, it is satisfying. 9 minus 1 minus 1, it is satisfying, means function is defined because we are working in real number. Let's say if you are taking this radius is 3, let's say if we will take 4 comma 4. Okay, so what will happen, it is 9 minus 4 square will be let's say if we'll take any point yeah, 4 comma 4, so it will be 16 minus 16. Now what is this, it will be not defined because it will be negative of square root, which is something complex number, and because of that we are working in a real number, it will not satisfy this. If you will take, let's say, any point, let's say you will take this 4 comma 0, then again what will happen, 9 minus 16 minus 0, again this is not defined. So it means simply domain means a set, at a set of points at which my function will be well defined. If any condition is there, then you have to write down like this. This is the proper way to write down the domain. Now come to the range, how to write down the range of the function. It is very, very important. Okay, just try to understand, just see the function. What is the function? So your function is f of x comma y, that is square root of 9 minus x square minus y square. Okay, so here what will happen in this case, you take the maximum value. What will be the maximum? Because of that it is minus of x square and minus of y square, so it is subtracting from 9. So what you can do, since you can write down, since x square plus y square will always be greater than equals to 0, because of that it is square, it is positive, always be greater than equals to 0. Okay, when you will put 0 comma 0, it will be 0 0. When you will put any value 1 minus 1 minus 1 comma 1 minus 1 comma 0, it will always be greater than equals to 0. So what will be the maximum value? So its maximum value, let's say maximum value occurs when x square plus y square is equals to 0. So simply x comma y is equals to 0. So when the function will take maximum, when it has 0 comma 0. So it means, what do you mean by, because if I will put, let's say if I will put 1 comma 0, so 9 minus 1 will be root 8. Okay, so when this will take the maximum value, when these both are 0, only this expression is there. So it will be 9 minus 0 square minus 0 square. So this function will take the maximum value as 3, and keep in your mind, whenever it is square root function, so always it will be greater than equals to 0, it will never be less than 0. So this is the maximum value. Then how to write down the range? So range will be from 0 to 3. 3 is including, 0 is also including. When this function will attain the 0, when simply your x square plus 9 square is equals to 9. If it is 9, then at the boundary of this domain it will give you the 0 value. Okay, and at the origin point it will give you the maximum value of this is something called range. So now whenever you have this square root function, you have to keep in your mind, whatever written inside, it should be greater than equals to 0, and whenever it is a square root function, you start from 0 and you find out the maximum value. How to find out the maximum value? You put 0 0 here if it is like this, or you just try to find out that point at which the function will get the maximum. Okay, this is just the, that obvious thing, you can easily get this. Okay, now come to the next question. Okay, now see how to solve this problem. This problem has two things. First of all, this is a rational function. It means this is a function of px over qx. you have to keep in your mind two things. First, whenever this kind of function arise, your qx should not be equals to 0. Second case, if it is a square root, then this should be greater than 0. So how to find out the domain for this function? So first of all, whenever you have this x square plus y square minus 4, according to the square root, okay, according to the square root rule, it should be greater than equals to 0. But according to this rational root, it should not be 0. It means it should be x square minus y square minus 4 strictly greater than 0. Because of that, the expression inside the square root must be positive and denominator can't be 0. So 2 points are there. Expression inside the square root must be greater than equals to 0. And second thing, because of that it is denominator, second thing is denominator must be non-zero. So here if you are containing 0, so according to this second point it will be greater than equals to 0. Okay, this is plus. So what is this meaning? So x square plus y square is strictly greater than equals to 4. So this is the condition. Okay, this is the condition. This is not the domain. Keep in your mind, this is not the domain, this is the condition. How to write down the domain? So this is the proper way to write down the domain. Collection of all those points belonging from R to such that they are following this condition x square plus y square which is greater than equals to 0. This is your domain. Now what is the geometric meaning of this domain? The geometric meaning is simply a circle or outside the area of the circle. Okay, this is your circle of radius 4, so this is the outside area of the circle. Okay, these point, if you will take these point, your function will create the at this point the like this will create the problem. Okay, so this is the meaning of this. Now how to find out the range for this? So whenever you have to find out the range for this kind of function, let's say you have z is equals to f of x comma y. Okay, this is the function. Now I will give you the trick how to find out the range. So this is your x square plus y square minus 4. So what to do? You take, let's say if I will set r square is equals to x square plus y square, and it means simply r is greater than of 4. So it means I have found out r is equals to r is greater than of 2. So now what is the function? So I can convert my function into a single variable. So z is equals to 1 upon square root of r square minus 4. Okay, now what will happen? Because of that you have to find out the range. You have to find out, because that it is a square and it is 1 upon something, so with what value it will be taking. So case number 1, you have to check the behavior. So case number 1, now you take the limit r tending to 2, because you got the critical point, this is the value, so you take r positive. So if you'll put the limit in the r positive, so you can simply write down like this: r square minus 4 tending to 0, it means it is square root of r square minus 4. It will be 0 when you will put this thing here. It means when you will put 4 here, or I can more precisely I can write like this: r square tending to 4 plus, then it will be something 0, it will be going to 0. If you will put r tending to r minus, it means I can write down the limit r square tending to r minus. So because of that it is r square, so it will be minus of this. Okay, so it will be something like this, minus of again it will give you the 0. Or if I will take r as maximum value, let's say if I will take r as infinity here, so then what will happen? R square is infinity, so it will be infinity minus 4, so it will be infinity. And one more thing, what you observe from here, it is going from 0 to infinity, and I told you whenever it is square root function, always your range will start from 0. What is the maximum value? For this maximum value is infinity. But keep in your mind, if you will put 0 here, if you will put 0 here, let's say x is equals to 0, y is equals to 0, if you will put 0 here, then what will happen? This will be square root of minus 4, and this will be not defined. So you can't include 0, but and also you can't include infinity. So this is the way proper way to find out the range. Okay, Again, if you are not understanding, again I will give you simple trick. Z is equals to f of x comma y, that is 1 upon square root of x square minus plus y square minus 4. What to do? Because of that, this is x square, then x square plus y square minus 4. First of all, range should be 0 to something. Now you check, if you will put 0 0 here, it means your x is equals to 0, y is equals to 0, and what will happen? It is minus, so it means you can't include your 0. Now you take, let's say, if it is 0, if this thing is 0, then will it take any, will it not take any of the value? It will take any value till infinity. It will not take any negative value because of it is a square root function, so it will be from 0 to infinity. With the obvious thing, you can find out this. Okay, take one more question, that is your logarithmic of s. Now how to find out the domain for this? Again, I explained you, whenever you have log kind of thing, whenever it is log mod of x, so this is called argument. So our argument always greater than equals to 0, so it means in your log of x y plus 2, your x y plus 2 should always strictly greater than of 2. It means your x into y should be greater than of minus 2. This is your condition. This is not the domain, keep in your mind, this is your condition. Okay, so the domain will be x comma y belonging from R2. It means the collection of all those points belonging from R2 which is satisfying the condition, that is x comma y greater than of minus 2. This is the domain, and this is the hyperbolic domain. Okay, because x y is greater than of this is called hyperbolic. Now how to find out the let's say range for this function? It is very easy. Again, with obvious thing you can find out, no need to go for the different things. Because of that, it is a logarithmic function, and the range of log is always minus infinity to infinity. You keep in your mind. Otherwise you can proceed like this. Let's say t is equals to x y plus 2, and now what is this? It is simple. F of x comma y is converted to your log of t, and log of t, the range of log t is minus infinity to infinity. Or you can write like this: when xy tending to minus 2 positive, and when xy tending to infinity positive. Okay, if you will put minus 2 here, then you will get infinity, minus infinity. You can put, this is your log of let's say minus 2 plus 2. Okay, this is your log of 0, and this is something minus of infinity here. Okay, again, because it is, you are going in positive side, okay, minus of this, so log of this. Or you can simply take z tending, or wait, let me explain clearly. So if you are taking, let's say z positive, so x into y is equals to minus 2. So it means, what is the t? T is equals to minus 2 plus 2, t is equals to 0. It means your t tending to 0. If your t tending to 0, which is log of 0, and which is something minus, because you are going positive side, this is minus of infinity. Okay, and if you'll take this as plus infinity, this will be plus infinity. Then, or forget about all these things. The range of log is always, because we know the graph of log t, it will be always minus infinity to infinity. So these were the three problems in which we have discussed the problem related to the domain. Now I have one more problem related to the domain and range. Now how to find out the domain and range for this function? Again, I explained you, this is a rational function px over qx. So it means here your qx should not be equals to 0. So what you will do? So you will simply take x square plus y square plus z square is not equals to 0. This is function of 3 variable. So in this case, this is the condition. Okay, this is the condition. And when this will condition happen? Okay, when this condition will happen, when, because all are positive, so this condition will be true for only 0 comma 0 comma 0. Because of that, all are positive. So simply you can write your domain like this: R3 such that minus of 0 comma 0 comma 0. Or also you can write down like this: x comma y comma z belonging from R3 such that x square plus y square plus z square is equals to is not equals to 0. Okay, you can write down your domain like this or domain like this. Because of that, it has a particular case. Okay, other than this it will never repeat. It has a particular case, then you can write down like this. And now one more thing, How to find out the range for this function? To find out the range for this function, again it is very simple. Because of that, it is polynomial function. Again, it is a polynomial, it is a polynomial rational of like ratio of polynomial. And when you will take, let's say, x equals to y equals to z is equals to t, so what you will get, you will get a function of t that will be t cube upon 3t square, and this is nothing but 1 by 3 into t. So what is this? This is a polynomial function, and you know that what is the range of polynomial function. So the range of a polynomial function is always minus infinity to infinity. There is nothing which your polynomial function will not get. So it will get each and every value from this. So this is your domain and this is your range. You can convert to a function of one variable and then you can check the range for this function. This is very easy to understand. Okay, this is how we can solve the problems related to the domain and range of function of two variable. Now move to the another topic, that is your level curves of a function of two variable. Whenever you will have a function of several variable or function of two variable, let's say like this, so level curves is something like that. A level curve is obtained by taking or setting f of xy is equals to c. So basically it represent all point in the xy plane where the function has the same value. So let's say if you have this paraboloid, okay, let's say this is the paraboloid in your like circle. I will simply write draw like this. Let's say this is the paraboloid. Okay, so if I will cut this paraboloid from, let's say, this plane, or from, let's say, this plane, this constant plane, then it will give me a circle of this, or you can say the locus of the particular point. Okay, so this is something called the level curves. On to how to find out the level curves, you put this equals to c and then you can get the level curves. So this is the step. So you start with the z is equals to f of x comma y, replace your z means this with constant c. Okay, and then simplify and identify the type of curve. You have to, whether it is a circle, it is a, let's say, it is any other curve, you can identify and then choose the different value of c for the multiple level curves. Okay, let's say if you have this question, how to find out the level curves for this. So find out the level curves of x square plus y square at the arbitrary different level. Arbitrary different level means you can choose by yourselves. So let's say I have this function as the step. This is f of x comma y, that is x square plus y square. Let's say this is equals to z. So what is the step one? So replace. So here you start with this. So here second step is replace z by constant. So you put z is equals to c, so you will get c is equals to x square plus y square. So what is this? This is nothing but a circle. Okay, this is the circle of radius root of c. Okay, so simply you can write the circle of radius root of c. Okay, then different cases. Let's say if I will write down my c is greater than of 0, then it will be x square plus y square is equals to c, where the radius is representing the circle of this. So it will represent the, now you can change the different radius. Let's say my r is equals to 1, then what will happen? It is x square plus y square is equals to 1. It is nothing but your circle of radius 1. Okay, if it is x square plus y square is equals to, let's say, 4, so it is representing circle of radius 2. Okay, if it is x square plus y square is equals to 9, then it will represent the circle of radius, let's say, circle of radius r is equals to 3. So these are different case. Okay, if it is, let's say, if your c is equals to 0, then what will happen? It is x square plus y square is equals to 0. It means your x is equals to 0, y is equals to 0. It will represent the origin. Okay, this is the different level curves. So if your let's say c is less than of 0, then there is no level curve, because x square plus y square is equals to c. Because of that, this is always positive, so there is no level curve. So it means whatever this graph, so this graph is something like this. Okay, this is the graph of x square plus y square. So in negative part there is no graph. Okay, so this is x equals to, this is x equals to 0, y equals to 0 this case. And all the circles of radius, let's say this is level, let's say this is r equals to 2, this is r equals to 3, these are different levels. So in negative part, you can see there is no curve. So this curve is always positive, so there is no level curve in the negative side. This is how you can find out the level curves of the different curves. Okay, so to find out the limit of function of several variable, there are different methods. So when you have f of x comma y, this is a function of two variable, and where x comma y is belonging from R2, then part 1 of this, what is the meaning of part 1? So whenever there is a question like take the path or direction and find the value, so there are two type of questions. So first type of question is the take the path and direction and then find the value of the limit. Okay, and along with the like all possible paths. Okay, part 2 is limit existing. So the different second type of question is something like this: value of L is finite or unique for each path or the direction, then limit like this is called limit exist. Limit exist means the value for each different path is existing, means you are getting some finite and unique value, then you will say your limit existing. If limit is not finite, if limit is not unique, okay, let's say your for first path you are getting L is equals to 0, for second path you are getting L equals to 1, this is not unique. This is not unique for that function, you will say your limit does not exist. Or if you'll say, let's say your limit is infinity, then also you will say it is limit does not exist. Let's say for first path your limit is let's say for first path limit is something 1. Okay, let's say for first path limit is equals to 1, second path limit is also 1, then you will say limit exist. So these are the different case. Now there are two types of problem based on limit of function. So problem number 1, so problem number 1 is like this: check the limit of function of x comma y, like find the limit of x square plus y square upon xy at 1 comma 1, check the limit of 4x square y x square upon y square. Then in this case, how to solve this type of question? So put direct values. So whatever the value, let's say it is 1 comma 1, so you can put direct value until unless if it is not giving you the indeterminate form. Let's say check for the undetermined form, it means let's say 0 by 0, 1 by 0, 1 power infinity. Let's say if you are getting these kind of problem, then simplify the expression as much as possible, you simplify the expression, and otherwise use the paths to check the limit of existence. We'll solve the problem, don't worry about this. If you have this kind of problem, prove that or show that, like show that limit of this is equals to 0, then you have to proceed with epsilon delta theorem that I'm not going to explain in this video. I will discuss this particular type of problem because of that in your exams, most of in your exam most of time you will get this problem. This for this problem you just comment the if you want this explanation, you comment, you like mention in the comment, then I will give you if you need this epsilon delta theorem. Because of that, most of time they will ask something question like this to find the limit, or we can simply find out the limit using the paths. Okay, if you have to prove, then you have to proceed with the epsilon delta theorem. That is the simple case. Now how to find out the limit for this? So first of all, let's say I have this question, then how to proceed for this? As I told you, whenever you are getting any of the question, find the value of the limit, then simple, what you have to do, let's start the solution. So your f of x comma y is equals to x square y minus 2xy plus y upon x into y plus y. You have to find out the limit at x comma y is equals to 1 comma 1. It means x equals to 1, y equals to 1. So you put these value in f of x comma y. It means you have to find out the value of f1 1. So put x equals to 1, it will be 1 square into 1 minus 2 1 into 1 plus 1. Okay, and then divide by 1 into y value is also 1 and this is 1. Now when you will solve this, what you are getting? So you are getting 1 minus 2 plus 1 upon this is 1 plus 1, so it is something this is 2 minus 2 upon 2, so it is 0. So it means it is finite. Okay, so it is not creating the problem. Let's say it is not giving you the undetermined form. So simple, you will say the limit of this function. So the answer for this, limit x comma y tending to 1 comma 1 for your function x comma y is equals to 0. Okay, so this is the simplest question you can get this type of problem. Let's say if you have the problem related to this. Okay, so here your f of x comma y is equals to x square minus y square upon x minus y. Again it is saying that x comma y is tending to 0 comma 0. It means your x is tending to 0, y is tending to 0. Then what will happen? You put these values directly. So when you will put these value, let's say 0 comma 0, it means it is 0 square minus 0 square upon 0 minus 0. So it is giving you the 0 by 0. It means it is your undetermined form. So what to do? So whenever you are getting undetermined form, step number 2. Okay, this is step number 1. Now step number 2. Step number 2 is your simplification. Okay, so what do you mean by the simplification? Can you simplify this function? Let's say I have this function x comma y is equals to x square minus y square upon x minus 1. Yes, I can simplify like this. It is x plus y and x minus y divided by x minus y. Okay, so here I can simply cancel this thing. So now after simplification, my function is x plus y. Now if I will put x tending to 0, y tending to 0, this is the limit of the function. Now if I will put this limit, so it means 0 comma 0, it will be 0 plus 0, it is giving me the 0, it is the finite value. Then I will simply say the limit x comma y tending to 0 comma 0 for my function x comma y, it is 0. So again this works for me. So this was step number 1 and step number 2. Now come to this problem, how to solve these kind of problem. Whenever you have this kind of problem, you simply write down like this. This is f of x comma y is equals to x square plus y square cos of 1 upon x into y. Okay, this is something we are called sandwich theorem kind of. So how to solve this kind of problem? Let's say if you have x square plus y square, so in this particular case we can use the concept of bounded. Okay, this is something called squeeze theorem, means sandwich theorem we can use. Okay, I will give you two methods to solve this problem. Okay, first step number 1. So what to do? Step number 1, here I explained you, because of that you have to check whether at 0 comma 0, so x tending to 0, y tending to 0, when you will put it here, 0 square plus 0 square, it will be cos of 1 by 0. It means it is in between minus 1 and 1, because cos infinity is in between minus and 1. So whenever you have this kind of problem, you can proceed like this. You know that whatever the value of cos of theta, it is always in between 1 and minus 1. Okay, always in between 1 and minus 1. So instead of writing cos theta, can I write down like this? It will be cos of 1 by x. Okay, I want this f of x here. Then what I will do? I will multiply both this side. What I will multiply? I will multiply x square plus y square all the sides. So it will be x square plus y square, and it is your cos of 1 upon xy less than of x square plus y square. There is a theorem known as sandwich theorem, or also known as squeeze theorem. Okay, this theorem is called squeeze theorem, or also known as sandwich theorem. Okay, so what is this sandwich theorem? Says that if you have any function like this, let's say it is your g of x comma y, okay, and it is your h of x comma y, in between if you have any f of x, if this function has limit exist at L and this function limit exist L, then of course this function will have limit at L. So we can take this x square. So now let's say my function h of x comma y, that is your x square plus y square. If I will put x tending to 0, y tending to 0, what is the value? That is 0. If I will take, let's say, g of x comma y is equals to minus of x square plus y square, if x tending to 0, y tending to 0, it is also 0. It means that my f of x comma y has the limiting value 0 0. So what will be the limit at x tending to 0, y tending to 0 will be 0 using this squeeze theorem. This is one of the method. Okay, or also you can proceed like this when x is equals to 0, y equals to 0, but it will be a bit difficult. But whenever you have this kind of problem in which any trigonometric function is there, let's say it is cos of 1 by x, or if it is sine of 1 by x, then also you can proceed like this, because sine is also bounded in between this. Okay, so this is the thing you can use in which your like solution of limit of the function of several variable. Okay, now come to the continuity of the function of two variable. Okay, before going to this, I want to explain one more question related to the limit of this. Let's say if you have this kind of problem, f of x comma y is equals to x square plus y square upon x cube plus y. If you have problem like this and find out the limit at 0 0, okay, find out the limit at 0 0. Now how to deal with this type of question? I will simply suggest you to check for the limit. You start from x equals to 0. Okay, if x equals to 0, then what will happen? If x equals to 0, so it is basically f of, so your limit like this, so limit y tending to 0, because x is equals to all x 0, y tending to 0, x is equals to 0, so it is 0 square plus y square upon 0 cube plus y. So it will be limit y tending to 0 and y square upon y will be y, and when I will pass the limit it will be 0. Second, y is equals to 0, it means something like this, x tending to 0, y is equals to 0, it is your x square upon x cube. Okay, instead of taking x cube, can I take x square here also? Okay, I can take x square here. Let's say if it is x square, it is also x square, it will be 1. Okay, simply you can say because of that these both limit are not equal, so limits are not unique here. Okay, limits are not unique. It means, because see, whenever I'm going to this path it is 0, I'm going to this path it is 1. Okay, so in this case you can simply say limit does not exist. Or if you want to check for the path, then which path you will take, that is very very important. If you will take y is equals to mx, or simply I will suggest you, if you have y square like this, then you put the denominator like this, x square plus y is equals to 0, then you choose which path you will choose. Not only this straight path, you can choose y is equals to x square also. If you have denominator like this, let's say x square plus y square upon x cube plus y square, then you can choose the path, you put x cube is equals to y square. Okay, then y is equals to x power 3 by 2. You can choose this path also. I'm giving the trick to the choose, like to choose the path. If you have x square plus y square upon x cube plus y, then you can choose the path y is equals to this. So to approach to hit the problem for the limit, first of all you take x equals to 0, second you take y equals to 0, third you take y is equals to mx. This is sufficient. Okay, this is sufficient. If any of limit does not exist, if let's say if any one of this is not matching with all, then you can simply say limit does not exist. Okay, you can simply say limit does not exist. Okay, if you have these kind of cases, then also you can proceed to this case. Let's say you can choose y is equals to x cube path, this is one of the next path. Okay, y is equals to x power 3 by 2 path. These are based on the denominator. Okay, these are the thing which is very important in terms of finding the limits of function of several variable. I hope you got it. Now come to the continuity of function of two variable. So how to find out the continuity? To find out the continuity, to check the continuity of any of the function, you should have an idea about the limit of the function. Your limit of the function should exist. So keep in your mind, continuity means it is satisfying three different point. First of all, f of x is defined at that particular point. It means, let's say if I want to check the continuity at 0 comma 0, then function should define at 0 comma 0. It means I should have the value of function at 0 comma 0. Second thing, limit of function should exist. It means this value, limit of this function should exist at that particular point. And third value, this first point and second point both equal. It means function value at that particular point is equals to the limiting value at that particular point. If all three conditions are satisfying, then I will say my function is continuous. Let's start with the problem. Again, it has two type of problem. First of all, check the limit, and second is the prove that this is the limit. If any question which is related to the prove that this function is discontinuous, then you have to use the epsilon delta theorem. Again, if it is like this, check the continuity of, then again I will discuss this theorem. I am not again I will discuss this particular type of problem. I am not going to discuss the epsilon delta theorem. If you want the explanation, I can give you explanation in a separate video. So if question asked in your exam like this, find out the limit, find out the continuity, or check the continuity whether my function is continuous or discontinuous. You can use this three condition. Keep in your mind these three condition which will help you out to solve the problems. This is very important and very easy to solve. Let's say I have the function that is I have this question, and this is given that check the continuity. Okay, this is the check, not proof. This is check the continuity. Then you use the simple ordinary method. So first write down f of x comma y, that is x into y and x square plus y square. So what is your first step? First step is your, what is the value of f of 0 0? So f, when x is equals to 0, y is equals to 0, it is given as 0. This is the first point. Second point, it means function is defined. What I will say, function is defined at 0 comma 0, because I want to check the continuity at 0 comma 0. Second thing, find out the limit at x comma y, that is 0 comma 0 of xy upon x square plus y square. Then I will use the path test. So what will be the path test? When x is equals to 0 and y tending to 0, it means it will be limit y tending to 0, put x equals to 0. When you will put x equals to 0, it will be 0 comma y upon 0 square plus y square. It will be 0. Limit, this is finite. Okay, then next point, y is equals to 0 and x tending to 0. It means limit x tending to 0, x as it is, y value is 0, x square plus 0 square, this is also 0. It is not sufficient to say that my function is, my limit is existing. Now I have to use the third path, that is my y is equals to mx. Okay, now when I will put y is equals to mx, it means I will simply use this x as x, okay, and y as mx. So it means here I can simply say limit x tending to, here I can say, because it is converted to the function of one variable, so limit x tending to 0, limit x tending to 0, x is as it is, y is mx. Okay, so this will be x square, y is mx square. This is the value when it is x square into m upon limit x tending to 0. X square I can take common, 1 upon m. X and x get cancelled, so it is limit x tending to 0. Because there is no x, then I can simply write down, because there is no expression of x, so it is m upon 1 plus m. Because of that, m upon m square, yes, so it is m square. Because of that, it is depending on m. If I will choose m is equals to 0, it is 0. If I will choose m is equals to 1, it is 1 upon 2. Now you see, if I will choose m equals to 1, this is 0, this is 1, and this is 1 by 2. It means this is not unique. This is not unique. When it is not unique, so limit does not exist. If limit does not exist, then this function is not continuous. So simply I will say this function, this f of x comma y, is not continuous because of that limit does not exist. Okay, so this point, second point, fails. It means this function is not continuous. This is very easy to understand. Now come to the next question. How to solve this question? Let's say if you have this question, then examine the inner part. Okay, if you have function like this, then you simply examine the inner part. Then how to examine, how to find out the limit at 0 0? So you take solution for this. First of all, you check what is the value of function at 0 0, that is given as 0. It means function is defined at 0 comma 0. This is the first step. Second step, what is the second step? Simply you take whatever written inside. So it is written x square plus y square. I think this is there is a typo. This is x square plus y square, like this. Okay, this is the question. So sine of, so your f of x comma y, or if I will simply take let f of x comma y is equals to xy upon x square plus y square. What is the value of this, that I will find out? So simply you take x equals to 0. When x equals to 0, it is 0. When y equals to 0, it is 0. When y is equals to mx, then what will happen? Because of that, it is the same question which we have solved. So here limit does not exist. If here limit does not exist, it means what will happen? So here what will happen? Sine 0 equals to 0. Okay, it is sine of something. Let's say it will be m upon 1 plus m square. So it will be sine 1 by 2. Okay, this is something different. Then again what will happen? Limit is not unique. If limit is not unique, then what will happen? This function is not continuous at 0 comma 0. Okay, so if this limit does not exist, then of course sine upon xy upon x square plus y square, limit does not exist for this function. Now come to the next question. Now how to solve this question? Again you start from the first point. So what is your first point? So what is the value of f of 0 comma 0? Because you want to check at 0 comma 0. This is given as 0. It means function is defined at 0 comma 0 at that point. Now second point, find out the limit x comma y tending to 0 comma 0 of my function, that is xy cube upon x square plus y power 6. Okay, then you take x is equals to 0. Then what is the value? If you will put x equals to 0, you will get 0. If you will put y equals to 0, you will get 0. Okay, by multiplying. Then you put y is equals to mx. Then what will happen? Limit x tending to 0. This is your x and this is your mx whole cube upon x square plus mx whole square, whole power 6. Now when you will solve this, then you will get it here, x power 4 into m divide by, and it is your limit x tending to 0, and this is divided by x square plus x power 6 upon m. When you will solve this, it will be limit x tending to 0, x power 4 m. You can take x square common. It will be 1 plus m into x power 4. When you will take x square common, okay, when you will take x square common, so it will be something like limit x tending to 0. This is x square into m upon 1 plus m into x power 4. When you will put this x as 0, okay, now you multiply, so this is 0 square into something, it will be 0. So it seems like it is 0, it is 0, and for this y is equals to mx, it is also 0. But one more thing that I explained you, whenever you have this kind of denominator, you don't follow 1, 2 and 3 path. You have to proceed for one more path. Now which path you have to take? Now you have to take x square is equals to y power 6. It means you take x is equals to y cube. You take this path also. Now you proceed with this path, or you can take y is equals to x power 1 by 3. You can also take this path, no worries. Y is equals to x power 1 by 3. Now let's say for more simplicity I will choose x is equals to y cube. Okay, so this will be my function. Now you just try to understand. I will take x is equals to y cube. What is my function? Function x comma y is equals to I think it is, okay, x y cube upon x square plus y power 6. This is the function. Now I will take this x is equals to y cube, or one more thing, I think this will be easy for you. You take y is equals to x power 1 by 3. Why? Because it is x square is equals to y power 6. So whenever we are taking y is equals to mx, instead of that you take y is equals to x power 1 by 3. Now you put the value, so it will be limit x tending to 0. So it is x as it is, y is x power 1 by 3 whole cube. This is x square plus y is equals to 1 by 3 power 6. And when you will solve this, it is x, okay, limit of, this is limit x tending to 0. This is x, 3 and 3 will get cancelled, so it will be x, this is x square into this is, oh sorry, plus this is also x square. So it is your x square upon 2x square, it will get cancelled and it is 1 by 2. So you just try to understand, when I have put the value of x, then I got 0. Y is equals to 0, I got 0. Y is equals to mx, I got 0. But y is equals to x power 3, this is also the path, this is also the path, this is 1 by 2. It means it is not unique. So if it is not unique, then limit does not exist. So if limit does not exist, then what will happen? This function is not continuous at 0 comma 0. This function is not continuous at 0 comma, okay, this is also not, you write it here, okay, so this function is not continuous at 0 comma 0. This is how we are finding, we are checking the limit for different possible of paths. This is very important, okay, you keep in your mind. Next come to the point, question number this question, okay, so I think this is question number 3 for the continuity. How to check the continuity? I am giving you the each and every case, okay, so I'll discuss this question now. Again, start with point number 1. So what is the value at 0 comma 0, at that point where which we are finding the value of function, that is given 0? It means my function is defined at 0 comma 0. Now again, check for the limit, check for the limit at 0 comma 0. Now how to check the limit? So it is limit x comma y tending to 0 comma 0, okay, for 3xy upon square root of x square plus y square. Now how to check this? You put x is equals to 0 along y axis, you will get 0. You put y is equals to 0, you will get 0. Now you put y is equals to mx, okay, when you will put y is equals to mx, it will be limit x tending to 0. This is 3x, y value is mx upon, so it is square root of x square plus m square into x square. When you will solve this, it is 3x square into m upon, it is, when you will take x square common, because of that it is x square, so square root, it will be x, and this is 1 plus m square, then x and x get cancelled, so it will be limit x tending to 0 3 into x m upon square root of 1 plus m square. And when I will put this value here, so here uh, this will be 0. Okay, when I will put x tending to 0, this is equals to 0. Now you see, this is limit 0, this limit is 0, this limit is also 0. It means now you will say limit exist. So now what you will say, so you can say limit exist here, limit exist at 0 comma 0. Now the third point, so what is the value of f of 0 comma 0? That is 0. And what is the value of limit at 0 comma 0? Okay, what is the value of limit x comma y tending to 0 comma 0 of f of x comma y? That is also 0. So these both are equal, then it means your function is continuous at 0 comma 0. So this is step 1, step 2 and step 3. You have to check in this form. This is the solution of question of checking the continuity of the function of two variable. I hope it is cleared to you. Partial derivative of the function. What is the partial derivative and why we are using this partial derivative? It is very important. So first of all, partial derivative of function of two variable. In function of one variable, if we have, let's say, y is equals to f of x comma y, then we were finding dy by dx. It means this is the differentiation with respect to one variable. Okay, if we have y is equals to, let's say, z is equals to f of x comma y, then here we can't get dz by dx, because here we have y also, so in this case we have to differentiate once with respect to x and next time with respect to y. This is something called partial derivative. It means like at a time we are differentiating with respect to one independent variable, that is called partial derivative with respect to that independent variable. And the rule is that whenever you are partially differentiating with respect to x, all other variables are constant. This is the notation for this. Okay, a partial derivative represents the rate of change of the function with respect to one variable while keeping the other variable constant. This is the meaning of the partial derivative, and these are the notation. So partial derivative with respect to x, partial derivative with respect to y. Okay, this is called first order partial derivative. It means first time partial derivative. If I will write like this, it means it is second order partial derivative. It means two times partial derivative with respect to x and two time partial derivative with respect to y. Some people are also denoting like this f, and in subscript it is writing x. Okay, it is f y when you have to define the second order partial derivative f x x, and this is f y y. Don't define like this. This is wrong. This is wrong notation. This is the correct notation. Okay, next. These are the formulas. Okay, so what will happen, how to learn this formula? These are the techniques, these are the formulas. There are two ways to solve the partial derivative of function of several variable. We'll see the different question, don't worry. So here what will happen, this formula, so whenever you are finding the partial derivative with respect to x, it means you have to this representing the change with respect to x direction. So it is something limit h tending to 0, h is representing the change, f of x plus h change in x direction, y is same, x is again this is function divided by h. If it is change with respect to y, now I will say partial derivative with respect to y, then what will happen? Then partial derivative with respect to y means now change in y direction. So what do you mean by change in y direction? So partial derivative of f with respect to y, limit k tending, now I am representing the change with respect to k. So okay, change in terms of k, so k tending to 0, x is same, y plus k divided by k. These are the simple formulas, and you can learn these formulas like this. Okay, by differentiating partial, again if you want to calculate the second order partial derivative, third order partial derivative, again you consider this as f and then write down the same formula for this. Okay, so there are two types of question to solve the partial derivative. Whether you can solve using this formula or you can proceed like this, single derivative. First, whenever you are differentiating with respect to x, keep y, z or all other variable are constant. Whenever you are differentiating with respect to y, keep x, z, all other variables are constant. So there are two types of question that we will see, and these are the different formulas. Whenever you are going to differentiate again partial derivative with respect to x, this is called second order partial derivative. It means you have to again differentiate, again you have to do the differentiation with respect to x. Again, this is the differentiation with respect to y. This is something called, first you are differentiating with respect to x, then you are differentiating with respect to y. And this is something called, first you are differentiating with respect to y and then you are differentiating with respect to x. And interesting thing is these both are same. This is called Clairaut's theorem. It means the partial derivative, first if you are doing with respect to x, then if you will do with respect to y, or first you are doing with respect to y and then if you will do with respect to x, these both are same. And this is very important concept of the partial derivative. Now come to the next. This is the type 1 question. Okay, find the partial derivative of function, solving direct method, or you can use this formula. And this is number 2 type, solving the partial derivative at a point. This is general partial derivative, this is the partial derivative at a point. So what you can do, after finding the value of the partial derivative, you put x equals to a, y equals to b. Otherwise, in this function, instead of x you write down a, instead of y you write down b. So these are 4 type of question. Okay, basically type 2 major types are there, 4 type of different things are there. First thing is that solving the partial derivative, simple, you can use this direct method that I will explain you. Okay, this is using the formula. Okay, you can also solve like this, like the formula. If they are saying find the partial derivative at the particular point, then first you solve this, put x equals to that point, y equals to that point. Or if you are using the formula, instead of finding the partial derivative, simply at x you put the value of x and you put the value of y. Don't worry, I'll explain the question, then only you will understand the thing. Let's start the question. I will explain each and everything. Let's say I have this question. Okay, so what is the question? F of x comma y is equals to x square into y plus 3xy plus y square. I will find out each and every partial derivative. So first of all, I will find out the partial derivative with respect to x. Then what do you mean by this? This is partial derivative with respect to x of x square into y plus 3xy plus y square. Okay, I can simply write down like this because it is linear, so I can write down x square y plus, it will multiply by here, it means it will operate here, 3xy plus this is partial derivative with respect to y square. So what will happen? Because of that, I am doing partial differentiation with respect to x, so my y is constant, so I will take y outside. So this is partial derivative of x square with respect to x. Here 3 is constant, y is constant, then partial derivative of x with respect to x. Here y is constant, then partial derivative of 1 with respect to x. So what will happen? Y as it is, what is the derivative of x square? That is 2x. Now 3 and y is constant. What is the derivative of x with respect to x? That is 1. This is y square. What is the derivative of 1 with respect to x? That is 0. What is the answer? So answer is 2xy plus 3y. This is the partial derivative with respect to x. You can simply find out in such a way. Now how to find out the partial derivative with respect to, now we'll find out the partial derivative with respect to, okay, wait, sorry. Yes, now find out the partial derivative with respect to y. So it will be partial derivative of f with respect to y. So now what is this? Partial derivative of y of x square into y plus 3xy plus y square. How to find out this? That is very easy. Okay, so this is something like this. Partial derivative of x square y with respect to y, partial derivative of y with respect to 3xy, partial derivative with respect to y of y square. Now you see x constant, then x square outside, partial derivative of y with respect to y, 3 and x outside, So partial derivative of y with respect to y. Now partial derivative of y square with respect to y. So this will be x square. Partial derivative of y with respect to y is 1. This is 3x. It is also 1 and it is 2y. So it will be x square plus 3x plus 2y. This is something partial derivative with respect to y. This is partial derivative with respect to x. Now if you want to calculate the partial derivative with respect to, okay, partial derivative, now again second order partial derivative like this. If you want to calculate partial derivative of f or second order derivative, so it means partial derivative with respect to x of partial derivative of x. What is the value of partial derivative of x? 2xy plus 3y. Then this is the partial derivative of x of 2xy plus 3y. Then simple, y is constant, 2 is constant, y and 2 as it is, partial derivative of x is 1. Okay, this is 3 into y, both are constant because there is no x term, so it will be 0, it will be 2 into y. So this is partial derivative with respect to 2 times x. Okay, now this is your x square plus 3x plus y. So what is the partial derivative with respect to y? It was x square plus 3x plus 2y. If you want to calculate second order partial derivative with respect to y, it is something partial derivative of this again with respect to y. So it is partial derivative with respect to y. What is the value of this? That is x square plus 3x plus 2y. Now partial derivative of y, partial derivative with respect to y of x square, there is no y term, it will be 0. Here it is also no y term, it will be 0. This is 2 into y and partial derivative of y is 1, 2 is constant, so the value will be 2. So f of y will be 2. Okay, now next I want to calculate the partial derivative of f with respect to x then y. So it means partial derivative of here x of partial derivative with respect to y. Okay, what is the value of this partial derivative with respect to y? This is the value you put like this. So partial derivative of this, it is x square plus 3x plus 2y. Now you do the partial derivative with respect to x, then y is constant, so it will be 2x plus 3. Okay, on the other hand, if I want to calculate the partial derivative first with respect to x, then with respect to y, it means partial derivative with respect to y of partial derivative of x. See difference, here I am writing y, here I am writing x. Then what is the partial derivative with respect to y that we have calculated earlierly? It is 2xy plus 3y. So it is 2xy plus 3y. Now you do the partial derivative with respect to y, that is x is constant, so it is 2x, partial derivative of y with respect to y is 1 and partial derivative of y with respect to this is 3. Now see the magic, this is, these both are same, this value and this value both are same. It means that partial derivative with respect to x then y is equals to partial derivative of y and then x, both are equal. This is very important. Okay, these are the all different partial derivative. So what was that? Partial derivative with respect to x was 2xy plus 3. Partial derivative with respect to y is x square plus 3x plus 2y. Partial derivative, second order partial derivative with respect to x, it was 2 into y. Partial derivative, that is second order partial derivative with respect to y, was 2 and partial derivative of xy is equals to yx is equals to 2x plus 3. So this is called partial derivative and this is we are calculating using the formula. Okay, this is using the formula. Now if they are saying, let's say if you have to calculate the partial derivative, let's say let me copy this. Okay, so if this is the question and they are saying that find out these partial derivatives at this point, it means you have to put x is equals to 0, y is equals to 1. We have calculated these are our partial derivative. You put the value. When you will put x is equals to 0, what will happen? When you will put x equals to 0, y equals to 1, what will be the value? So the value will be 3. This is something called at 0 comma 1. Now at 0 comma 1, what is the value? X is 0, x is 0, y is 1, that is the answer 2. Now again in this, again if you will put 0, you will get 2. If you will put 0 comma 1, this is already 2, so it will be 2. When you will put 0 comma 1 here or 0 comma 1 here, x is 0, this will be 3. This is the one of the method. So here we have solved two type of question. What was the question? First is simple finding the partial derivative. Second is finding the partial derivative at a particular point that is given as 0 comma 1. The same partial derivative you can calculate using your formula. Now we'll say, sir, simply show us using the formula that what is the partial derivative with respect to x. Let's say it is limit h tending to 0, f of x comma y, sorry, what was the formula? F of x plus h comma y minus of f of x comma y divided by h. When I will apply this formula, then also I will get the same 2x plus y plus 3. How we will get? Just see. So what is x plus h? So you replace your x with x plus h and y as it is. Okay, so it is your limit h tending to 0. So your f of this is your f, that is x square. It means x plus h whole square into y plus 3 into x plus h into y plus y square minus f of x comma y minus this. So this is your x square. Okay, wait, let me readjust this. Okay, so it is x square into y plus 3xy plus y square divide by h. Now solve this. So you will get limit h tending to 0. It is x square plus 2hx plus h square plus you solve this. This will be 3xy plus 3hy plus y square minus this is your x square y. Okay, x square y minus 3xy minus y square. So y square and y square get cancelled. Okay, then x square y here. Okay, this is multiplied with y, sorry for that. So here multiplied with y. So can I multiply y here and y here? So this x square y, this will get cancelled. 3xy, this will get cancelled. So what you will get from here, this is your h. So this is 2hxy, because this term is remaining. I can highlight this term is remaining, this term is remaining, and this term is remaining. So it is remaining 2hxy and h square y plus 3hy divided by h. Now you see, when I will solve this, then what will happen? If it is like this, 2h, I can take h common, because limit h tending to 0, I can take h common. This is 2xy okay, 2xy plus this is hy plus, because this is h square, I can take h common, and this is 3y divided by h. So h and h get cancelled. So from here I can get the value, and if I will put h0, this will be 0. So I can get the value 2xy plus 3y. I think this is the answer. I think y is not here. Y, I think there is one mistake. When I will multiply, this is 3xy, x plus h, 3hy. Wait, let me check again. I think this is also y here, because when I will take the partial derivative with respect to, okay, this is y also. See, this is f of xy na, 2xy plus 3y. I am just checking this, sorry for that. So this is y here, sorry, this is y here, then answer is same, this is correct. Okay, so what will be your answer? So your answer will be this this is the partial derivative. See, this is the partial derivative with respect to x, 2xy plus 3y. See, this is 2xy plus 3y. I can get the same answer with this. Okay, this is how we can solve this using our method. Okay, using our formula. So this is how we can solve. Anyway, so you can use this formula and that simple concept I explained you with the both the formulas. Now come to the next point, how to solve this question, how to find out the partial derivative of this solution. Again, we will solve all the partial derivative again. So what is your f of x comma y? That is x square into y plus x into sine y. Okay, so first find out the partial derivative with respect to x of x square y plus x sine y. Keep in your mind, whenever you are partially differentiating with respect to x, all other are variable. So what it will be? So partial derivative with respect to, see, partial derivative of x square y, what is this? It will be 2xy, and partial derivative of x of second term x sine y, x is 1, this will be sine y. So what is the partial derivative with respect to x? It will be 2xy plus sine y. Okay, now partial derivative with, this is first one, partial derivative with respect to y. So when you will do the partial derivative with respect to y, I have to write down here x square y plus x into sine y. X is constant, so x as it is, partial derivative of y with respect to y, it is y only, so it is 1. So x is constant as it is, derivative of sine is cos y, so the answer is x square plus x into cos y will be the derivative of this. Okay, now come to the next, this is the second. Third one is the second order partial derivative. So partial derivative with respect to x of partial derivative with respect to x. So what is the value of this? So it is partial derivative of 2xy plus sine y. See, this is the fx, so you can find out. Again, my y is constant, 2 is constant, y is constant, derivative of x with respect to x is 1, plus there is no x term, so it will be 0, so the answer will be 2y. Okay, now find out the partial derivative, second order partial derivative with respect to y again. So it is your x square into x square plus x into cos y, and the partial derivative with respect to y, there is no y term, so it will be 0. Okay, so it is x and derivative of x is minus sine y, so it is your minus x sine y. Okay, similarly you can find out the derivative, let's say your fxx. Okay, you have, now you have to find out the fxy is equals to fyx. Okay, so this is the question. So what is your fx first of all? So your fx is 2xy plus sine y, it is 2xy plus sine y. What is your fy? That is your x square plus x cos y, so it is x square plus x cos y. So using this, can I find xy? It means first derivative is this, so it means this is the partial derivative with respect to y of this. So this is partial derivative of y of 2xy plus sine y. With respect to y, it will be 2x constant, y derivative of y with respect to y will be 1, derivative of sine y with respect to this will be cos, so it will be 2x plus cos of y. Now what is this yx? It means derivative of f of xy with respect to x. So how to find out this? So the derivative with respect to x of this is your x square plus x cos y. What is the derivative of x square? That is 2x. What is the derivative of x? That is 1. Cos y will be same. You can see these both values are same here. In such a manner you can find out the value of this. Okay, now come to the next question. See this question. In this case, how to find out all the partial derivative we will also see. So let's say it is x square plus y square. So f of x comma y is equals to x square plus y square plus e to the power, oh sorry, not x square, this is x square minus y square. So this is x square into y square plus e to the power of x plus y. Okay, instead of like this, can I write like this? X square y square plus e to the power x into e to the power y. I can also write like this. So whenever you have this, then you can write like this. Now find out the partial derivative with respect to x. Y is constant. Partial derivative of x is equals to 2x. E to the power y constant. Derivative of e to the power x is same. So what is the answer? 2xy square plus e to the power x plus y is the answer. Okay, partial derivative with respect to y, it will be also the same like this. So x square constant, it will be 2y plus e to the power x constant, derivative is this. So the answer will be x square or 2x square y plus e to the power of x plus y. Now come to the partial derivative of second order partial derivative with respect to x. That is again partial derivative of this is equals to 2y square, because x is 1, and it will be e to the power of x plus y as it is. Okay, next come to the next point. Okay, that is your uh, partial derivative with respect to y, second order partial derivative. So 2x square as it is, y will be 1, and this e to the power x plus y will be same. Now partial derivative with respect to x and then y, this is my f of x. If I will take the partial derivative with respect to y of this, so it is something like this. Okay, so partial derivative with respect to y of partial derivative with respect of x, so this will be partial derivative with respect to y of 2xy square plus e to the power x plus y. Then with respect to y, it will be 4xy plus e to the power x plus y. When you will solve this also, then also you will get the same like this yx. So it is nothing but with respect to x of partial derivative with respect to y, it is also 4xy plus e to the power y plus x. In such a way, you can find out the partial derivative. Okay, now come to the next question. Whenever you have this type of question, now how to solve this question, in which you have to use the product rule. Okay, like this. So what to do in this? So first of all, find out the partial derivative with respect to x. So it is the partial derivative with respect to x, and this is x into y, this is sine xy. So product rule is what? U into v rule. Okay, so what it is, y is constant, you take y outside, and this is x into sine xy, because this is function of x and y both. So you consider it as u, it as v. So y, okay, first you take the derivative of u. So sine xy as it is, but derivative of x with respect to x is 1, plus then x is as it is, derivative of sine x is cos of x into y, constant, y is constant, then again the derivative of x y with respect to x, then y will be outside, because you know that sine ax, what is the derivative of sine ax? It will be cos ax into a. So y is constant, so y will come outside. Okay, this is the general simple thing. Then what will be the solution? So it will be y sine of xy plus x y square cos of xy. This is the partial derivative with respect to x. Now what is the partial derivative? Okay, if I will find out the partial derivative with respect to y, sorry, it is not 2, then it is partial derivative with respect to y, xy sine xy. Then here x is constant, partial derivative with respect to y sine xy. Because of that, this is the function of x and y both. Now you consider this as u, this as v. So it will be x. First sine xy as it is, partial derivative of y with respect to y, it will be 1, plus y as it is, it will be cos of xy. Now your x is constant, then multiply x, then it is your x sine xy plus x square y cos of xy. This is the partial derivative with respect to y. Now I hope you can easily find out all other partial derivative. This is for your homework, you can find out. Okay, I can give you the answer, you solve, and you get these answers. So basically the answers are this: 2y square cos x into y minus xy cube sine x into y. Okay, you can match your answer with this. So the fyy will be 2x square cos xy minus x cube y sin xy, and fxy will be sin yxy, okay, sin xy, sorry, plus 3xy cos xy minus x square y square sin x into y, which is also equals to fxy. So you can match your answer with these answers. So you try this question, then also you will get it. Okay, now come to this. Whenever you have this kind of problem, how to solve the partial derivative? As I explained you, you have two things. First, you can solve using the ordinary method, or you can solve using your formula. But I will suggest, whenever you have this kind of formula, because of that, in this formula you have to use v upon u upon v formula of derivative. That is something v square, v outside. Okay, so v outside derivative of u, then u outside derivative of v. Instead of using this, it will be very complicated to solve this. Then you use formula. Okay, so which formula? Because of that, it is, you have to find out the value at x comma x equals to 1, y equals to 1. So you have to find out the partial derivative of x at x equals to 1, y equals to 1. So what is the formula of partial derivative? So with respect to x, that is your limit h tending to 0 f of x plus h y minus f of x comma y divide by h. So this is your limit h tending to 0. What is the value of x? That is 1. You put it here. So it is 1 plus h, y is equals to 1, f of 1 comma 1 divide by h. Now what is your f of x comma y? That is x square plus y square. So what is the value of x? That is 1 plus h. So you put limit h tending to 0, 1 plus h whole square plus 1 square upon 1 plus h plus 1 minus 1. So it will be 1 square plus 1 square upon 1 plus 1 divide by h. You solve this. So when you will solve this, you will get limit h tending to infinity. It will be 1 plus h square plus 2h plus 1 upon 1 plus h plus 1. It will be 2 plus h. Okay, 1 plus 1 will be 2, 2 plus h minus, it will be 2 by 2 upon, it is h. So it is simply h tending to 0. Can I write 1 by h? Okay, because it is divided by h, I can write 1 by h. What it is? It is 2h. Okay, it is 2 plus 2h plus h square upon 2h minus 1. Now I can take, if I will take h common, so it will be limit h tending to 0. Okay, so when I will solve this, so it will be something denominator like this. So wait 2h. Okay, so it is, now you multiply h here, it is 1 by h. So now you multiply h here, so you will get, when I will multiply h, 2 plus 2h plus h square 2h, this. Okay, so how to simplify the denominator? Okay, so can you take like this? So it is 2 plus 2h minus h square minus 2h. Can I take like this? Taking the LCM, then this and this will get cancelled. So it will be limit h tending to 0, 1 by h. So now it is 2 minus h square upon 2h. Okay, so 2 minus h square upon 2h. I think there is one problem. Let me check it. 1 minus 1. So it is 2 plus 2h plus h square. Oh, sorry. It is 2 plus h. Yeah, it is 2 plus h. Sorry. It is not 2 into h. It is 2 plus h. That's why it is making the mistake. So it will be, wait. So 1 by h, it is 2 plus h in denominator. So 2 plus 2h plus h square. When I will take, it will be minus 2 minus h divided by 2 plus h. Now this 2 and this 2 will get cancelled, then 1 by h, it will be 2h. Okay, 2h minus h will be h plus h square upon 2 plus h. Okay, so what is your expression? So your expression is, wait, so your expression is 1 by h. Okay, limit h tending to 0, it is h plus h square upon 2 plus h. Now from here, can I take h common? So if I will take h common, it will be 1 plus h, 2 plus h. H and h get cancelled. Now you put h equals to 0, you will get 1 by 2. So what is the partial derivative with respect to x? At 1 comma 1, it is 1 by 2. So this is very easy when you have this kind of formula. Okay, now let's say if you have this, again find out the partial derivative with respect to x at 0 comma 0. Then again I will use the formula. Then okay, instead of finding at x, I will find out at y. So it will be different question for you. Okay, so it will be f of okay, so limit, so now it will be limit k tending to 0, it will be f of x, okay, y plus k minus f of 0 0 divide by k, limit k tending to 0, x is, put x equals to 0, y equals to 0. Okay, instead of this I have to write down xy here in the formula, so it will be x and y. So now it is 0 0 plus k minus f of 0 0 divide by k. Okay, so what is the value at 0 0? At 0 0 the value is 0. Okay, at 0 0 the value is 0, and if I will put x equals to 0, it will be limit k tending to 0, so it will be 0 square plus k square. Okay, 0 plus k is the k square, divide by 0 plus k minus 0 divide by k, so it will be limit k tending to 0, so this k square by k will be k minus 0 divide by k, and it will be 1. So what is the answer of partial derivative with respect to y at 0 0? That will be 1. Okay, in simple manner you can find out the value of this partial derivative. Okay, so now when when you will use this formula and when you will use the simple method, if you have any function like this, then use the formula. If you have any question like this simple, then you use our ordinary method to find out the partial derivative. This is the simple trick for you guys, you can use this. Okay, now come to the partial derivative. This is something called chain rule of the derivative. Okay, so partial derivative, here I will write using chain rule. So in this question, in this case, so the chain rule like help to differentiate composite function. What do you mean by composite function? So it is FOG, means let's say if it is sine x into y, if it is sine x square, okay, there are two functions, that is sine x and x square. When I will take the composite, then I will get sine x square. Okay, so in this case, how to solve that type of formula? So sorry, that type of problem, then there are the formulas. Type 1, let's say if it is w is equals to f of xy, x is depending on t, y is depending on t, then what will happen? What is the formula? It is to find out dw by dt. This is called chain rule. It is ending on t. Okay, then partial derivative of f with respect to x, because it is depending on two variable. Okay, my function is function of two variable, then I will take the partial derivative, so it will be partial derivative of f with respect to x. Then again, x is depending on t, because of that my x is depending on t, that's why I will write down this dx by dt, because x is depending only on t. You just try to understand. This is my w is depending on x and y, so that's why let's say it is f of x comma y, that's why I will find out the partial derivative of w or partial derivative of f with respect to x and partial derivative of y f with respect to y. Because x is depending on t, y is depending on t, only one independent variable, then I will find dx by dt, and it is dy by dt. Now you multiply this and this and then take the addition of this. So this will be your formula, dou f by dou y, okay, dou f by dou x into dx by dt plus dou f by dou y into dy by dt. This is how you can write down the formula. Second trick, second type of question is this: if your w is this, okay, w is f of x comma y. Now w is depending on x and y, but x is depending on r and s, y is also depending on r and s. So I can write down like this: x is depending on r and s, y is also depending on r and s. Now just try to understand, whenever you have function of two variable, then you have to use the partial derivative. So here we will find out the partial derivative with respect to x, partial derivative with respect to y, but here we will find out the partial derivative with respect to r of x and partial derivative with respect to s. Here partial derivative with respect to r and partial derivative with respect to x. Now which one is to use in which formula? If it is asking find out the partial derivative of w with respect to s ending with s, try to understand, ending with s, then all are ending with s. See, ws fx xs fy ys. If it is ending with, let's say, r, or if it is written as t, then I can write down also t. Okay, if it is written as t, then see, dou w by dou t plus dou f by dou x by dou t. Why I am using partial derivative here and it is ordinary derivative? Because here x is depending on only one variable, here x is depending on two variable. Again it is partial derivative concept. Okay, don't worry, I'll give you the question and then we'll solve the question and we'll find out the value. So what is the question? Question number 1, w is equals to x square y plus y square. Now it is x is depending on, this is depending on x and y. X is depending on t, that is t square plus 1, and y is depending on t, that is e to the power of t. Okay, so what is the formula to finding out this? I will simply tell you whenever you have to find out this, because x is equals to t square plus 1, y is equals to e to the power of t. Okay, now what is your target? Target is dw by dt. So what is the formula? dw over dou w over dou x, means partial derivative with respect to x, because w is depending on x and y, into x is depending on only t, plus w is depending on y, into y is depending on only t. So now find out the partial derivative with respect to x. So it is, you know, the partial derivative, that is 2xy plus 0. Partial derivative with respect to y, it will be x square plus 2y. This is the formula. Okay, so this is x square plus 2y. Sorry, it is cube. Okay, so it is square, so it will be 3y square. I think this is the, yeah. Now find out dx by dt. It means this is your dx, derivative with respect to t, it will be 2t. Now dy by dt, et, so e to the power t is simple e to the power t. Now you put these value here, dw by dt. What is this? 2xy. What is the value of this? So the value of this will be dx by dt is 2t. Okay, then plus what is the value of this? That is your x square plus 3y square, and what is the value of this? That is e to the power t. Then what is the answer? So your answer is 4xy. Now you see, just try to understand. Because of that, I am finding out the partial derivative with respect to t. So what is this? So this is 4xyt plus this is x square into e to the power t plus 3y square into e to the power t. This is dw by dt. Now what is the value of x? That is t square plus t square plus 1. What is the value of y? That is e to the power t. You put the value here. So 4 into t square plus 1, e is e to the power t into t, plus x square is equals to t square plus 1 into e to the power t, plus y square will be 3 e to the power 2t into e to the power t. Now you simplify this, you solve this, you will get the solution of dw by dt. Again you have to see, whenever you are differentiating with respect to t, you convert your xy into your t. This is one of the important thing. This is how you can find out the solution. This is at t is equals to 0. So now what to do? We got this thing. Now you put t is equals to 0. Okay, so I will simply copy this thing. This is our dw by dt that I can write down here. Okay, this is our dw by dt. So dw by dt. Now what is saying that find out the value at 0. Okay, dw by dt at t is equals to 0. So you put t is equals to 0, 0 plus 1 e to the power of 0. Okay, and multiplied with 0. So what is this? 0 square plus 1 e to the power 0 plus 3 e to the power of 2 into 0 into e to the power of 0. This will be 0 because multiplied with 0. This is also, this will be 1 plus 3. So the answer is 4. You can find out the value like this. This is how you can easily compute the value at the different point. Okay, so if they will ask you this type of thing, then you can simply solve like this. This is how you can solve, or you can find out. These are the two different questions. Now come to the next point. Again, this is function of several. Now if it is function of 3 variable, how to deal with this? Simple concept. First of all, w is equals to x square plus y square. Okay, x square plus y square plus z square. X is equals to cos of t, y equals to sine of t, okay, and z is equals to t. What will be the formula of dw by dt? This is the question. Start with partial derivative with respect to x, partial derivative with respect to y, partial derivative with respect to z. X is function of t, so dx by dt, dy by dt, dz by dt. This is the formula. That's it. Now you find out all the formulas. So partial derivative of w with respect to x, it will be 2x, it will be 2y, it will be 2z. Partial, now derivative of cos t, it will be minus sine t, it is cos of t, and it is 1. Now x is equals to cos, then it will be 2 cos t into sine t plus 2, y is equals to sine t, so it will be sine t into cos t, plus z is equals to t, so it will be 2t. This is the answer. Now if it is like this question, this is something called partial derivative with respect to r and this. Now this is another type of question. So what is the question? So here you have the question is, see, you have the question is w is equals to x plus y plus z whole square. X is equals to r minus s, y is equals to cos of r plus s, and z is equals to sine of r plus s. It means x is, see, here x is depending on only t, here x is depending on r and s. So what is the first formula? So first you have to find out the value of dw by, sorry, not d, partial derivative of w with respect to r. How to find out? It is again very easy. Partial derivative of w with respect to x, partial derivative of w with respect to y, partial derivative of w with respect to z, because this is function of 3 variable. If it is not, then you write up to here. Now because of that, x is depending on r and s both, and we are calculating r, so do the partial derivative of x with respect to r, partial derivative of y with respect to r, partial derivative of z with respect to r. Okay, this is the formula. Now you can find out the formulas easily. What is the partial derivative of w with respect to x? So it will be 2x plus y plus z into 1. Okay, so it is something like this. Partial derivative of x square is equals to 2x. X is your x plus y plus z, chain rule. Okay, plus into, what is the partial derivative of x with respect to r? It will be 1. So here it will be 1. Partial derivative of w with respect to y, it is 2 of x plus y plus z, and partial derivative of x is 0, y is 1, z is 0, so it will be same. What is the partial derivative of y with respect to r? Because of that, it is cos of r plus s. Derivative of cos is minus sine r plus s, and derivative of r plus s will be 1. R is 1, s is 0, so this will be the derivative. So what will be the derivative of w with respect to z? It will be 2 of x plus y plus z, and derivative of partial derivative of z with respect to r, it will be cos of r plus s. Now what to do? Can I take this as common? So if I will take this as common, so it will be 1 plus or 1 minus sine r plus s plus, I think it is, okay, I have taken 2 common, so it is cos r plus s. Now what to do? X, y, z, you put the values of x, y, z. So what is the value of x? That is r minus s. Y is equals to cos of r plus s. Z is equals to sine of r plus s into multiplied with 1 minus sine r plus s plus cos of r plus s. Now when you will multiply all the terms 1 2 3 4 1 2 3, when you will multiply you will get 7 terms, and you can get the complete answer. Now it is saying find out the value at pi by 2 comma pi by 2. Then what to do? Instead of solving, you simply put pi by 2 here. So it is 2, r is pi by 2, s is pi by 2 plus cos pi by 2 plus pi by 2 plus sine pi by 2 plus pi by 2. Okay, then 1 minus sine pi by 2 plus pi by 2 plus cos pi by 2 plus pi by 2. So what will be the answer? So the, I think answer will be, wait, so here the answer will be, this pi by 2 will get cancelled, so it will be cos pi plus sine pi 1 minus sine pi plus cos pi. We all know that cos pi is equals to minus 1, sine pi is equals to 0, it is 1, sine pi 0, cos pi is minus 1, this and this get 0, so the answer will be 0. Similarly, now the next point, how to find out the partial derivative with respect to s. How to find out the partial derivative with respect to s. So what is this? Partial derivative with respect to x, partial derivative with respect to y, partial derivative with respect to z. It is ending with s, then you also end with s. So partial derivative of x end with s, okay, into partial derivative of y ending with s, partial derivative of z ending with s. So these are the formula, or you find out all these value and you put x, r is equals to pi by 2, s is equals to pi by 2, and then solve the question. This is for you, you can easily solve this question. Okay, so this is how you can get, and for your verification this will be the answer. So 4 will be the answer for this question. Okay, so you try and you get this answer, because I solved one problem. This is for your homework. Now come to the next topic. This is something called finding extremal and saddle point. Now what do you mean by extremal? It is something local maximum and local minimum. So f of xy is the function of two variable. Okay, then the local maximum, local minimum, and saddle point. Local maximum means the maximum point, minimum means the lowest point, saddle point means at which neither maximum nor minimum. Okay, so this is something, let's say I have this function, then okay, this is also maximum, this is maximum, this is also maximum, so these all are maximum, these are called local maximum, and these all are minimum, these are called local minimum. So maximum of maximum is this is called global maximum, or also known as absolute maximum. Okay, how to find out the maximum? You follow the step number 1. Given function f of x comma y, find out the partial derivative with respect to x and partial derivative with respect to y, and put that partial derivative is equals to 0. When you will put the partial derivative is equals to 0, you will get two equation number 1 and equation number 2. Using these both equation, find out the value of x comma y. These x comma y are known as critical point. It is not necessary that every time you will get only 1 point. You may get 2 point, 3 point, or more than 2 or 3 points. Okay, what is the second step? This is the second step. While finding the partial derivative, in the second step you find out the second order partial derivative with respect to x, with respect to y, and fxy. Okay, so second order partial derivative with respect to x, with respect to y, and the second order partial derivative with respect to x and y. And this is the formula: d is equals to fxx fyy minus fxy. Okay, means partial derivative with respect to x square into second order partial derivative with respect to y square minus this one xy. This is your formula. Now you find out the value of d at x comma y. When you will find out the value of d, your x naught y naught at the critical point. Okay, at the critical point there are three cases: d is greater than 0, d is less than 0, d is equals to 0. When you have three cases, look for only d greater than 0 while finding out the minima and maxima and minima. If d is not greater than 0, let's say if it is negative or if it is 0, then simply say function has saddle point. It means whatever the critical point you got it, these are saddle point, neither minima nor maxima. This is one part. Second part, if it is greater than 0, then come to the partial derivative with respect to xx. If this partial derivative at your critical point x naught comma y naught is greater than 0, then you simply say it is minima. If it is greater than 0, then it is minima. If it is less than 0, then it is maxima. If it is equals to 0, then you simply say this is called saddle point again. So whenever you have d less than 0, d equals to 0, and f of xx is equals to 0, your function will have saddle points. Function will have saddle point, nature will be saddle point for these critical points. Okay, this is the flow. This is something called derivative test of finding the extremal and saddle point. Now come to the point, how to find out the global maximum and global minimum. To find out the global maximum, global minimum, you repeat the step 1. It means to find out the critical point, it will be same. But second thing, check whether critical points are satisfying the condition or not. It means in this case, with your question, they will give you some bounded reason. They will give you bounded reason instead of, see, here it is, they are giving you simple f of x. Here they will give you some bounded reason, or you will say constraint. So whether that point are satisfying or not. If that point are not satisfying, you remove that point. If they are satisfying, then go to step number 3. Step number 3 is find the value of function at all critical point, interior point, and boundary point. All critical point which you got from here, interior point if it is bounded region, let's say if it is circle, then all inside point. Boundary point means all these boundary point. Then check the maximum value and minimum value of the function. You will get the maximum and minimum. We'll solve the problems for both the cases. Let's say we have this question. Okay, for this question, if we will find out the value of maximum and minimum, how can we find out the value? This is something called related to the local maximum and minimum. We will proceed with the derivative test. So first of all, I will find out the step number 1, partial derivative. This is step number 1, partial derivative of this, that is 3x square, y will be 0, so it is minus 3. Okay, then I will put this is equals to 0, then it will be x square is equals to 3 by 3. It means x square is equals to 1, so x is equals to plus minus 1. Similarly, I will find out the partial derivative with respect to y. It will be 3y square minus 3, because this is 0, this is 0 with respect to y. Then it will be 0, so now it is y square is equals to 3 upon 3, so y square is equals to plus minus 1. So what are the critical points I'm getting? I'm getting critical points. X is equals to 1, x is equals to minus 1, y is equals to 1, y is equals to minus 1. You make the pairs. So the critical points that I am getting, that is 1 comma 1, 1 comma minus 1, okay, minus 1 comma 1 and minus 1 comma minus 1. I am getting 4 critical points. I have to find out the nature of all the critical points, whether it is maximum, minimum or saddle point. Okay, now I will find out second step. I will find out the partial derivative, second order partial derivative. It means dou 2f by dou x square. This is dou f by dou. If I will again partially differentiate this, then it will be 6x minus 0. So it will be only 6x. Then I will find out again partial derivative of this with respect to y. So again it is also 6y. If I can find out fxy, which is also equals to fyx, that I explained in the previous topic. Okay, so let's say if we are taking this thing, if I will do the partial derivative with respect to y, it will be 0. If we will take this, then partial derivative with respect to x, it will be 0. Okay, that you know how to find out this derivative. Now in this step I have to calculate d. So what is the formula of d? That is fxx into fyy minus fxy whole square. So it is 6x into 6y minus 0 square. So it is your 36x into y. So this is the value of d. So d is equals to 36x into y. I have the critical point 1 comma 1, minus 1 comma 1, 1 comma minus 1 and minus 1 comma minus 1. One by one I will check for all the points. So first of all I will take x is equals to 1. I will take first critical point 1 comma 1. What is the value of d at 1 comma 1? It is 36. 1 into 1, it is greater than 0. It is greater than 0. Now you see, come to the point. This is our thing. See, when it is greater than 0, then you have to check for the partial derivative, how partial derivative is behaving. Now come to this. What is the partial derivative with respect to x? That is 6x. X is equals to 1. It is 6. It is also greater than 0. If d greater than 0 and f of xx is greater than 0, then this is minimum. This is minimum point. So this point is minimum, or more precisely you will say it is local minimum. What is this? Local minimum. Okay, so at this point function is attending local minimum. Now we will say what is the value. So value at 1 comma 1. So what is your f? F of x comma y is equals to x cube, okay, plus y cube minus 3xy minus 3x 3y. You put 1 1, so it will be 1 plus 1 minus 3 minus 3. It is 2 minus 6, it will be minus 4. So what is the minimum value? So minimum value is minus 4. See, this is minus 2 minus 2. This is the minimum value. This is the point at which it will occur the minimum value. Now come to the next point. Okay. Now what is the next point? Next point is check at b point at 1 comma minus 1. Now d is equals to 36, x is equals to 1, y is equals to minus 1, d is equals to minus 36. Minus 36, d is less than 0. When d is less than 0, it is saddle point. So this point is saddle point. It means it is neither maxima nor minima. Now C point, it is minus 1 comma 1. So d is equals to 36, x is equals to minus 1, it is 1, it is minus 36 less than 0. Again it is a saddle point. Okay, neither maxima nor minima. Now come to the next point. So what is your next point? So your next point is equals to d point, that is minus 1 comma minus 1. Now d is equals to 36 minus 1 minus 1. D is greater than 0, it is plus 36. If d is greater than 0, then I will check for the partial derivative of x. It is 6x When I will put minus 1, x is equals to minus 1, it is minus of 6, which is less than 0. When d is greater than 0, fxx is less than 0, it is the case of maxima, or more precisely I will say it is local maximum at this point. What is the value at minus 1 comma minus 1? That is your f of x comma y minus 1 cube plus minus 1 cube 3 minus 1 minus 3 minus 1, it is 1 plus 1 plus 3, sorry, minus 1 minus 1 plus 3 plus 3, it is 6 minus 2, it is 4. So this is the maximum value and this is the minimum value. So from here, what is the conclusion? So the conclusion is, for this I can make the conclusion. Now you can make the table like this. So x comma y, that is 1 comma 1 minus 1 comma 1 1 comma minus 1 and minus 1 comma minus 1. Okay, this is the nature and this is the value. So this 1 comma 1 is minimum, this is, sorry, this is minus maximum, this is your saddle point, this is your saddle point. Minimum value is minus 4, maximum value is 4, and these are the saddle points. So you can make this table. This is the proper way to find out the solution for this question. Okay, this is the important question. Now come to next. Find out the absolute maximum and absolute minimum for this function. Absolute maximum and absolute minimum. And one more thing, whenever if you want to calculate absolute maximum, absolute minimum, they will give you the reason. X square plus y square is equals to 4. This is the circle. This is a circle. Now you just try to understand how to see what is this bounded region. You just try to understand this bounded region. So this is basically a circle. Okay, so wait, yeah, so it is something like this. I have this circle, I can draw, wait, okay. This is the circle of radius 2. Okay, this is the circle. X square plus y square is equals to 4, and it is saying that in first quadrant. So find the absolute maxima and minima of the function. This is the given domain or region for my function f of x comma y, that is x square plus y square minus 2x plus 2. In this region, this is the region you find out the absolute maxima minima. How to find out the absolute maxima minima? First step is repeating. It means first of all you find out the partial derivative, okay, with respect to x. That will be your 2x minus 2 is equals to 0, so x is equals to 1. Then partial derivative with respect to y, that will be 2y. Okay, so it will be 2y, and when you will do the partial derivative with respect to y, it will be 0, I think. Y is equals to 0. So here you will get, it is 2y is equals to 0, then y is equals to 0. Okay, so what critical point you got it? That is 1 comma 0. This is not only the critical point, because of that it is saying first quadrant, and 0 comma 0 is also the critical point. And one more thing, you can do one thing, substitute into f, whatever your f if you are getting. In this case, if you want to get the critical point, what you have to do, you have x square plus y square is equals to 4. So you simply replace, you put y square is equals to 4 minus x square. You put it here, then you will get x comma 4 minus x square. So it is x square plus 4 minus x square minus 2x plus 2. So it will be x square plus 4 minus x square minus 2x plus 2. This will get cancelled. This will be 2 plus 2. So this will be 6 minus 2x. This is the equation number 1. This is one of the critical point. You can find out the critical point like this also. That's the reason. Now you see this is 6 minus 2x. Okay. Now what you do? You find out the range of this. So what is the range of x? Because of that, yeah, it is first quadrant. So x will vary from 2 to 0. So your x will vary from 0 to 2. Okay, so now you put x is equals to 0. When you will put x is equals to 0, so it will be 0 comma, see in this put you x is equals to 0, so it will be 0 comma 4, so it will be something 6. Okay, so okay, let it be. First of all, this is basically the test for this. You do one thing, instead of doing this, whatever the critical point you got it, this is the critical point, that is 1 comma 0. What will be the interior point? You take the interior point, let's say if I will take any interior, this is the interior point, I think this is here only. See, this is 1 comma 0, and can I take 0 comma 1? I can take 0 comma 1, which will show this boundary. Can I take any boundary point? Boundary point which is satisfying this. So I can take this is 0 plus 2, or I can take like this, I think 2 plus 2. Okay, so not 2 plus 2, root 2 plus root 2. So root 2 square plus root 2 square, which is also satisfying this. I can take root 2 root 2. Okay, so you simply find out this, and this is also 0 comma 0. Now you find out the value at 1 comma 0, because 1 comma 1 is not satisfying. I think, yeah, 1 comma 1 is satisfying for this. 1 square plus 1 square is less than equals to, see, this is equals to 0, because of that it is the region, bounded region, and it is equals to this, then you can, it is not given less than of this. Okay, so you do the boundary analysis only. So it will give you the maximum value at this point. Before going to this, let me clear one thing. How can you get the critical point or the boundary point? Wait. So what to do? You take the boundary point. This is your 2 comma 0. Okay, 2 comma corner point, basically you can say 2 comma 0 and 0 comma 2 and 0 comma 0, and this is your interior point, that is 1 comma 0. This is sufficient to check. Leave it. This is sufficient to check. Now it is the function, find out 2 comma 0, find out the value of 2 comma 0. This will be 4, okay, plus 0 minus, okay, 4 plus 0, this is 2, and you can find out the value, that is 2 plus 2. Yeah, 0 plus 4, I think, sorry, this is 4, because I'm just multiplying, this is 4 plus 2, because when you will put 2 here, it will be 4. 4 and 4 get cancelled, it is 2. At point, this is the value of 2. Now put 0 comma 2. You take the critical point, sorry, corner points. This is the corner, this is the corner, this is the corner. Okay. Now you find out 0 comma 2. You put x equals to 0, y equals to 2. When you will put x equals to 0, y equals to 2, you will get 4 here. When you will put 0 0, you will get 2. When you will put 1 1, wait, it is plus 2, then it is 6. Yes, it is 6. It is 2. When you will put 1, x equals to 1, so it will be 1 plus 0 minus 2 plus 2, you will get 1. So simply from here, this is your minimum value and this is your maximum value. That's it. What to do? Just, okay, let's take one more example, I think. Okay, before going to this, let's take one more example. I can take like this. Bounded region I can take. Let's say for this same question, x square plus y square minus 2x plus 2. Let's take this region. Okay, this is 2 comma 2. Then what to do? It is in this, basically you have to do the boundary analysis. So how to do the boundary analysis, I am giving you. What are the critical points for this? First of all, x is equals to 0, it means y-axis. Y equals to 0, it means x-axis. Okay, then let's say this is your x equals to 2, this is your y equals to 2. What are the critical points here? 0 comma 2. Okay, 2 comma 0, 0 comma 2, 2 comma 2 and 0 comma 0. So you find out the value at 2 comma 0. Okay, 0 comma 2, 2 comma 0, 2 comma 2, 0 comma 0. Then also you find out at this point, let's say this is something 1 comma 0. Okay, then you find out here this is 0 comma 1 and any point in between, let's say 1 comma 1. If you will find out at all these points, definitely you will get something in this. Okay, so this is something called check the values of point at different points, but it should satisfy the condition, whatever the condition. If they are not, if I will take any point from here, let's say it is 3 comma, okay, let's say it is 3 comma 1. It is not satisfying this condition, it is not satisfying this reason. It means y is less than of 2 and x is less than of, which is not satisfying this condition. If it is not satisfying this condition, I can't take that as a critical point. Okay, this is the simple concept to finding out the extremal of a bounded region. Now come to the next. This is the very important. Finding the extremal using Lagrange's method. Why we are using? First of all, it is mentioned, it will mention in your question paper that find out using the Lagrange's. Okay, this method is applicable for both bounded and unbounded region. This is very important. Okay, again they will give you some condition along with this to find out the maxima and minima. How to find out? Just try to understand. In this we are using the concept of slope. This is the gradient basically. So the gradient of f is equals to lambda times gradient of g. We are constructing new function. G is the condition basically. So what you have to do, you have to find out two different things. First of all, partial derivative of f with respect to x is equals to lambda times partial derivative of g with respect to x. Another equation will be partial derivative of f with respect to y is equals to lambda time partial derivative of g with respect to y. Using these both, equation number 1 and equation number 2, get one relation in x and y, and then using that condition find the critical point. That's it. Now again, after finding the critical point, find the value of function at the critical point and then decide which one is maximum, which one is minimum. Let's start with one problem. Okay, this is the question. So first of all, which one is fx and which one is gx? So this function is fx. So your f of x comma y, we are finding the extremal for this function, that is your x square plus y square, such that subject to there is one condition. So this will be your g of xy, that is your xy is equals to 1, or I can simply write down xy is minus 1. Okay, is equals to 0. This is something like this. This is your gx. Now what to do? Find out the partial derivative of f with respect to x, lambda time partial derivative of g with respect to x. What is the partial derivative of x? That is 2x into lambda time partial derivative of this g with respect to x. It will be y. Then it is 2x minus lambda time y is equals to 0, equation number 1. Next, partial derivative of f with respect to y, lambda time partial derivative of g with respect to y. So it will be 2y is equals to lambda time, what is this? Partial derivative with respect to y, it will be x. So what is this? 2y minus lambda x is equals to 0, equation number 2. What will be the third equation? Because we have three unknowns. What unknowns? X, y and lambda. So the third equation will be x minus y is equals to 0. This is equation number 3. Every time you write like this, find out this first equation, second equation, third equation will be your condition. Okay, this is the condition. Now how to proceed forward? You have to find out the relation between this. How to find out the relation? Okay, the equation we got is this 2x equals to lambda y. Okay, 2y equals to lambda x and xy minus 1 is equals to 0. Can I find lambda from here? Lambda is equals to 2x upon y. From here, lambda is equals to 2y upon x. Now I can equate, because lambda is unique for this, I can equate both this. So it will be 2x upon y is equals to 2y upon x. So it is something 2x square is equals to 2y square. 2 and 2 get cancelled. So x square is equals to y square. It means x is equals to y. This is the relation in between this. X is equals to y. So from here, what can I do? If I will use this relation in this, so it will be x square minus 1 is equals to 0. So x square is equals to 1. X is equals to plus minus 1. Because of that, x is equals to y, so y is also plus minus 1, so that I have critical point. What are that critical point? That critical points are 1 comma 1, minus 1 comma minus 1, 1 comma minus 1, minus 1 comma 1. I have 4 critical point. I have to check whether my critical points are satisfying the condition or not. What is the condition? My condition is xy is equals to 1. Now when you will put this condition, it is satisfying. When you will put this minus 1 into minus 1 is 1, this is also satisfying. But when you will put this condition 1 and minus 1, you put 1 and minus 1, this is not satisfying. So this I can't use. When you will put this I can't use. It means at this point extremal will not exist. So 1 comma 1, now find out the value at 1 comma 1. When you will put 1 comma 1 in your function x square plus y square, your f of xy is equals to x square plus y square. When you will put, you will get 2. When you will put minus 1 comma minus 1, again you will get 2. It means maximum and minimum occurs at maximum and minimum will occur at both the cases. It means here the thing is, now you have to decide whether it is minimum value or maximum value, because it is very difficult to choose. Now how to choose that, whether it is maximum or minimum? Since x square plus y square is tending to infinity, because it is a polynomial function, because mod x plus mod y tending to infinity, okay, mod x or mod y tending to infinity, and xy is equals to 1. This is the constraint, this is the condition. So in this case it will not be maximum, it will be minimum, because what is the minimum value for this function? Minimum value will be 2. Minimum value will be 2. Because of that is it's x square plus y square. This is the paraboloid in function of 2 variable. It will go up to infinity. There does not exist any of the maximum value for this. So how to decide? You can check your function. Your function is a polynomial function. It will take minimum at some point but maximum at infinity, because it has also the condition. So it will also take maximum at infinity. So this point is your minimum point, this is not maximum. You can decide like this, okay? This is the thing. Let's solve one more question so that it will be very easy to understanding you. Let's say if I have the problem like this, f of x comma y is equals to x square y. The condition g of x comma y, I can write down x plus y minus 3 is equals to 0. Then first of all you find out the partial derivative with respect to x into lambda partial derivative of g with respect to x. Okay, so it will be 2xy is equals to 1. See, this is here it will be partial derivative will be 1 only. Okay, second thing, partial derivative of f with respect to y, lambda partial derivative with respect to y. So it will be x square only, and lambda into it is also 1. Okay, so from here, okay, this will be lambda. So can I find the value of lambda? So from here lambda is equals to 2xy. Here lambda is equals to x square. I can equate both this. So it is your x square 2x. Okay, so okay, wait, before going to this I will write down the third one. Third one will be x plus y is equals to 3. Now using both this I will write down 2xy is equals to x square, or I will write 2xy minus x square is equals to 0. It is, if I will take x common, then it is 2y minus x is equals to 0. So from here x is equals to 0 or 2y minus x is equals to 0. It means I got the critical point as x is equals to 0 or 2y minus x is equals to 0. It means 2y is equals to x. These are the value. Now from here I have the condition. What is the condition? Third equation is x plus y. So third equation is x plus y is equals to 3. If x is equals to 0, then y is equals to 3. So this is the critical point, first critical point. Okay, if x is equals to, if let's say x is equals to 2y, if I will put here, okay, if x is equals to 2y, then it will be 2y plus y is equals to 3, then it will be 3y is equals to 3, then y is equals to 1. So when y is equals to 1, x is equals to 2, so 2 comma 1. So here I got two critical point, 0 comma 3 and 1 comma 2. Now you check these both are satisfying my condition or not, whether these both are satisfying. Okay, so 0 comma 3 and 2 comma 1. What is my condition? That is x plus y is equals to 3. If you will put it here, it is satisfying. If you will put this here, it is also satisfying. Now you find the value at 0 comma 3 and at 2 comma 1. So what is your function? So your function is equals to x square into y. So 0 square into y, it is 0, and x square into y, it is 4. So this is your minimum and this is your maximum. This is how you can solve the you can solve this maximum minimum function using the Lagrange's multiplier solution. I hope this video will be helpful for you guys and you will show the support for this video. So thank you for watching this video. Keep watching MS Maths. Please like, share and subscribe this channel so that I can upload this type of video in future for you guys, and it is very like important topic, so you please watch this video like till the end. And thank you so much for again watching this video. Thanks for watching this video. Keep watching MS Maths. Please like this video, share with your friends. Thank you. Bye bye.